Hello, my name is Andrew Triantafilou. I'm the tutor for the BEACTIVE project for AMable, and we'll be having a short interview to see how the experiment went. My first question is if you could just briefly tell us who you are and what you do as an SME and in the experiment as well.
So, BioG3D is an R&D company specialized in the field of additive manufacturing technologies, reverse engineering and biomaterial development. Our goal is to explore new materials and design approaches combined with the incomparable flexibility of 3D printing technologies to create customized products that incorporate smart functions that until now could not be produced by conventional production.
Okay, thank you very much. So could you just explain for people watching the idea or product that you had in mind when you applied for this experiment?
Okay, so BEACTIVE experiment targets the development of personalized medical assisted devices, along with the development of composite thermoplastic materials with advanced functionalities towards a new generation of patient-specific treatment. The main drawback here of typically used medical assistive devices is the lack of customization. This may lead to insufficient support and may cause discomfort to the recipient, while the highly hygroscopic nature of the currently used materials for the development of assistive devices enhance the bacterial growth. Now, BEACTIVE aims to improve discomfort and skin infections using antimicrobial materials, while 3D printing assistive devices are tailored to user-centric design.
Okay, thank you. So I think you've described the idea generally. If you could just summarize out of all of that, what additive manufacturing offers you, what you're expecting to get from additive manufacturing in this project?
So within BEACTIVE, 3D printing were combined with reverse engineering and generative design to enhance the development of personalized products with advanced functionalities and complex and lightweight structures by taking into consideration the specific anatomical feature of each patient.
Okay. And also, I think it's to do with the ability to tailor the material properties as well. I think that was also something that additive could help you with.
Yeah, the possibility for customization of the materials itself, it's a big help for us in order to introduce functionalities such as antibacterial properties.
Yeah. Okay. Thank you. And during the project, you had the option of using one or more of the services that are offered by the AMable platform. Can you briefly describe which services you chose and why you chose them?
Yeah. So as you already know, we started with the service of the design for AM from the Manufacturing Technology Center, where we received consultation of the effective exploitation for the patient's biometric data and the development of medical assistive devices that fully matches to the design requirements. And another service that we selected to be provided, namely modeling and simulation from Frederick University of Cyprus, in order to evaluate the mechanical stresses applied to the device while used from the patients, which led to the establishment of the design approach targeting the optimization of the device's open lattice structure through simulation. So we received results based on the discussed and agreed applied forces with the simulation team, and we utilized them for the design optimization.
Mm-hmm. Okay, thank you. Those two services, I think we can say, were of help to you. Can you just generally say how being part of the AMable project helped you realize what you were trying to in this experiment? In other words, what was the benefit you gained from having support from AMable?
Mm-hmm. Of course. So for us, the participation in AMable gave us the opportunity to collaborate with other SMEs across Europe that are interested in AM techniques for the medical sector to create final products. By effectively combining different scientific fields, new market opportunities have been arising. The holistic approach now, starting from composite filament production, personalized design to manufacturing and post-processing, constitutes to competitive advancement compared to the current 3D printing approaches in the field of medical assistive devices.
Okay, thank you. And as far as the custom fit splint, do you have a plan of when the product will be available on the market?
Hopefully, BEACTIVE products are foreseen to reach the market soon, since validation tests regarding the final device functionality are ongoing to evaluate their overall approach from material production to design, manufacturing, and post-processing activities.
Okay, that's great. Okay, and just generally, as a kind of to wrap up, what was the experience been like working with the AMable project?
The AMable gave us the opportunity to collaborate with a multidisciplinary team that covers almost all the supply chain for the development of 3D printed splints, from the material development, product manufacturing to the end user. Therefore, BEACTIVE faced all the possible challenges during production steps, giving a wide range of improvements, which leads in a final product with enhanced properties regarding the manufacturability and the end user satisfaction. And except that, the AMable gave us the opportunity to get services that were not covered from our know-how, while giving us the guidance during the BEACTIVE development, which led in product one step before market supply.
That's great. Okay. So yeah, that wraps up the determination interview. Thank you very much, and I wish you all the best for your future work in additive manufacturing.
Thank you. Thank you as
much.
well very much.
Okay.